Hello everyone. So today we are going to go with the indefinite integration level 1 mains model. So each and every model will be covered in this session. See that you be active in the complete session, concentrate and gear up for the exciting journey of integration with me. Right, so let us go with the first question. That is summation r equal to 0 to infinity x to the power r3 power r by r factorial dx. This is our question. So just expand the summation, substituting your r equal to 0, r equal to 1, r equal to 2, r equal to 3, so on. So what do we get? So that is your x to the power 0, 3 to the power 0 by 0 factorial, x power 1, 3 power 1 by 1 factorial, x square 3 square by 2 factorial, plus x cube 3 cube by 3 factorial, plus so on. It continues, and the integral of this dx is our question. Right. So rewrite this again. So that is 1 plus 3x plus, so observe 3x whole square by 2 factorial plus 3x whole cube by 3 factorial plus so on till infinity. Now, which expansion does it look like? So does it look like your e power x equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial plus so on? This is the expansion of e power x. So just replacing your x by 3x will be giving your answer there, right? So this is nothing but integration of, it is nothing but 3 to the power 3x dx. Now, what is the integral of e power x? E power x integration is just e power x, isn't it? So, but e power 3x, that is your e power 3x upon 3 plus some constant c, right? So that's your first question. Now, coming for the second question. Cos 2x minus cos 2 alpha by cos x minus cos alpha dx. Now, how do we get this? Now, when you observe cos 2x, what is cos 2 theta? Which is nothing but in terms of cos theta, if at all, we have to replace that. So cos 2 theta is 2 cos square theta minus 1 or 1 minus 2 sine square theta. So which one could be the better question? Now, like, which is the best substitution here, in the sense as the denominators are in terms of cos, we just go with in terms of 2 cos square theta minus 1. So cos 2 theta is replaced like 2 cos square x minus 1 minus, please use a bracket there, cos 2 alpha is 2 cos square alpha minus 1. I am just looking at the numerator part only. Solve the numerator, then include your denominator. Right, this is 2 cos square x minus 1 minus 2 cos square alpha plus 1. So minus 1 plus 1 got cancelled. So you can just take a 2 cos square x common. So 2 cos square x minus cos square alpha, which you can split it like a square minus b square, which is a plus b of a minus b, right? So cos x plus cos alpha times cos x minus cos alpha. Clear? That is your numerator. Now include your denominator too. That is your cos x minus cos alpha. Now integral of this dx, and now terms get cancelled here. So you're left with the 2 integral of cos x plus cos alpha dx. Now think about and tell me, what is the integration of cos x? Cos x integration is sin x, isn't it? So it is nothing but 2 sin x plus, and here cos alpha, alpha is a constant. It is not a variable there, isn't it? So cos alpha is a constant. Hence, it is nothing but cos alpha into 1. 1 integration is nothing but x. So there is nothing but x cos alpha plus c. So this will be your answer there. Clear at that? Well, now observe the question. So cos x by cos x plus alpha. This is our question. Now, how do we do this? Now, denominator here, you can split it. But numerator, yes, it cannot be done any further. So cos x plus alpha, you can split. So we need to think about, like, if we have this cos x plus alpha or something in the numerator, it would be a better approach to solve. So for that reason, what I am going to do is, you are just given this, but what we are going to include is plus alpha and minus alpha here with x there. So now what is the reason behind this? This is x plus alpha and alpha. So this is just like your cos A minus B expansion. Now cos A minus B. What is cos A minus B? That is your cos A. Cos B plus sin A sin B. So this is your cos A cos B plus sin A sin B. Now the whole upon cos x plus alpha here, and here also cos x plus alpha. Now we are able to split the numerator. So here also dx you take it, and here also you take it. Now there are terms getting cancelled here. So cos x plus alpha gets cancelled. What are we left here? Cos alpha, which is nothing but a constant here. So cos alpha into integral of 1. Integral of 1 in the sense x dx only, x plus c. Plus, now here, which are the terms which are getting cancelled? Nothing is getting cancelled, and sine alpha is a constant. You can just bring it out, and integral of sine by cos, which is tan x plus alpha. Right? Now, what is the integration of tan x? Integration of tan x is log mod secant x, isn't it? So that will be your log mod secant x plus alpha plus c, and rest all remains the same. This is your x cos alpha plus so and so plus c. Is that clear? Right, coming for the fourth question. So integral of 1 by sine x minus a into sine x minus b is there. Right, so your denominator, you cannot do anything. You need to have that in the numerator to solve something, but we don't have anything in the numerator. And I cannot place any variable there, isn't it? So x and all, I cannot place it, but constant, I can always take it. Multiply and divide by 2, multiply and divide by 3. And this I can do, multiply or divide by a or a minus b or something like that is what I can do there. So for that reason, how do I proceed with this question? See, if you have your a and b as your constants, right? So think about carefully, how can I recreate x minus a and x minus b using my a and b? That is what we need to think, right? See, suppose if I take a minus b, observe carefully, if I take a and minus b, so plus x and minus x if I am placing there. So here I cannot get, I need to have x plus a. I need to have x minus a, but not x plus a, isn't it? So this will not be my choice at all, right? So what should I go with? So if I take a and b, if it is minus x and minus x, if I am taking, let us consider this way. So just take a minus sign in common in between these two. So then what do you get? X minus a minus x minus b plus x, isn't it? So now these both are getting cancelled and you got a minus b here. Understand? So what I am trying to do is a minus x and b minus x. When I am subtracting these both, I am getting it this way. Because when I'm just taking x minus a and x minus b, I cannot end up with that, isn't it? So what did I take? A minus x minus b minus x is what I took it. Or rather than that, you can also do it this way. We need x minus a. So if I remove a minus sign common from this, I can get x minus a. And here also, if I remove a minus sign common, minus of minus plus x minus b, isn't it? So finally, what I can conclude, this is nothing but x minus b minus x minus a, right? Which is the same as multiplying your a minus b on both the numerator and your denominator, right? Okay, so this is all the rough column what we have done. This a minus b is what I'm multiplying and dividing. So 1 by a minus b integral of here also a minus b by all my denominator in the same way I'm writing without any sign change. So 1 by a minus b times. So this is nothing but what I would consider here is, let me consider, oh, not just a minus b, dear, just a minute. That should be a sine a minus b, isn't it? We need a sine a minus b. So let me write a sine a minus b. Sine A minus B here also, and sine A minus B here also. All right. Now let us talk about this. Now sine A minus B is there. Sine A cos B minus cos A sine B, isn't it? So I would take sine A cos B minus cos A sine B. But what is that A and B? So this A minus B is same as writing x minus B minus x minus A, isn't it? So by my denominator. So this is again 1 by sine A minus B. Now what is sine x minus B minus x minus A? This is like your complete A and complete B. So which is nothing but integral of sine A cos B minus cos A sine B. Apply very carefully. So this is a sine A cos B minus cos A and sine B. Right. Now whole upon your denominator. Denominator is sine x minus A, x minus B. Here also sine x minus A of sine x minus B. All right. So now there are terms which are getting cancelled. That is your sine x minus B got cancelled. So you are left with cot x minus A here, minus here sine x minus A, and sine x minus A is getting cancelled with the cot x minus B dx, right? So 1 by sine A minus B. So now what is the integration of cos? So integration of cot. What is cot x integration? Which is nothing but log mod sine x, isn't it? So cot x is log mod sine x plus c, right? So here you can just take 1 by sine A minus B times. So cot x minus A, which is nothing but log mod sine x minus A minus again cot, this is nothing but log mod sine x minus B plus C. That's it. So that is your fourth bit. Did you all understand that? So what we have done here, we have recreated the question by multiplying and dividing by some constant value, that is my sine A minus B. Because this A minus B is what I have started with, and I have taken minus x and plus x. So A minus x, B minus x. So we can get it to that form, isn't it? So if it is A minus x and B minus of B minus x, so I can just take a minus sign common from here. I get x minus A. And here also this is nothing but x minus B. So it is directly x plus B minus of x minus A, because I cannot multiply and divide with some variable there, isn't it? So I need a constant value to be done there. So hence I have considered sine A minus B as the factor there. Understood? So multiply and divided by sine A minus B. And that sine A minus B, obviously that A minus B is replaced with x minus B minus x minus A. Now this is your x minus B is your complete A, x minus A is your B. So hence sine A minus B forms sine A cos B minus cos A sine B. With your denominator terms get cancelled, you're left with cot x minus A and cot x minus B. Right? So now it is just an integration of what you can do for integral of cos x is what you end up with your answer there. That's it. Now, observing the question, tan x, tan 2x, tan 3x dx. So this has got a trigonometry base there. So a rule based on trigonometry. Remember, if a plus b plus c equal to 180 degrees. So obviously a plus b equal to 180 minus c, when you apply tan on both sides. So you get tan a plus tan b by 1 minus tan a tan b, which is nothing but minus tan c. Now all these get multiplied there, and you just get it like tan A plus tan B plus tan C is nothing but your tan A, tan B, tan C. So this is the most important law of trigonometry. So not only 180, any multiple of 180. Wherever you have A plus B plus C equal to any multiple of 180 degrees or n pi, you just have a rule tan A, tan B, tan C is same as tan A plus tan B plus tan C. So product tan A is nothing but your summation tan A. Right, so applying that technique here, but observe something and tell me, is it a multiple of 180? Do we know whether it is x plus 2x plus 3x is 180 or not? Unfortunately, we don't know that, isn't it? But 180 or any multiple of 180 is what given. So any multiple of 180, see, I can also take a plus b plus c equal to 0 degrees also. But can I get 0 here? How can I get a 0? When I'm adding x, 2x and 3x, where is the possibility of getting a 0? So one possibility what I can find is minus x plus minus 2x plus 3x can give me 0, isn't it? Understanding that fact, right? So then what can I take? So is it nothing but tan minus x plus tan minus 2x plus tan 3x? Is it nothing but equal to tan minus x tan 2x into tan 3x, because it is just an application of a plus b plus c is n pi tan a plus tan b plus tan c is tan a into tan b into tan c. Clear? Right. Now observe this. Now the product of these, this is also tan minus 2x here, right? So this is what I'm just rewriting my question with the minus x minus 2x. So rewriting the question like this, tan minus x and tan minus 2x. Even if I write it this way, there is no problem. I'm not at all changing my question. What is the reason? Tan minus x is minus tan x, one minus comes out. Tan minus 2x, another minus sign comes out, minus into minus turns out to be a positive, which means I am not changing my question at all, right? So tan x into tan 2x, sorry, tan minus x tan minus 2x into tan 3x dx. This is what our question is. Now, this can be written, the product of these values can be taken to be the sum of the same values, isn't it? So now I'm rewriting the question like minus tan 2x plus minus tan, yeah, this is a tan x, I will consider tan x and tan 2x plus tan 3x dx. Is that clear? So product of values is given. I am writing them to be the sum of values. Now from here onwards, you can just apply your integration of tan x. What is integration of tan x? Log mod secant x, isn't it? So log mod secant x minus log mod secant 2x and plus log mod secant 3x is what you can have. Understood? Clear at that question? Right. Now going for the next question, that's most important one. Yeah. Yeah, for the upcoming question, that is sin x cos x by cos 2x. So whenever you have sin x cos x, so the best thought, because this is in cos 2x, we can get an opportunity of having sin 2x also, provided, what is it? Sin x and cos x by under root cos 2x dx is what we have. We can just multiply and divide by 2 in trigonometry. In most of the cases, wherever you find sin x and cos x, just multiply by 2 and 2, multiply and divide by 2, so that your sin x cos x will be changed as 2 sin x cos x, which is nothing but your sin 2x there, isn't it? These three together, I can go with a sin 2x value, right? So that is sin 2x by under root cos 2x dx. Is that clear? Right. Now coming for, there is some suitable substitution what we can do here. Let cos 2x equal to t, let it be. Now when cos 2x is t, tell me what is its differentiation. Cos 2x differentiation is minus sin 2x into differentiation of 2x, that is 2 dx equal to dt, right? So now observe here carefully, sin 2x dx. This sin 2x dx is replaced with minus 1 by 2. So our sin 2x dx can be written like minus 1 by 2 dt. That is what I am replacing here. That minus 1 by 2 is taken out here, dt by root t. Is that clear? Right. Now from there we can do, isn't it? So what is root t? Root t, 1 by root t. 1 by root t ante actually t to the power minus 1 by 2 integral. So this is minus 1 by 4 integral of t power minus 1 by 2 dt. Now from here, t power minus, so this is minus 1 by 4 times t power minus 1 by 2 plus 1. So x power n integral, what is it? Integration of x power n is x to the power n plus 1 by n plus 1 plus c, isn't it? So t to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. Clear? So from here, you can just later on substituting your t value with what we have assumed is a must. Please do remember that. Yes, the seventh question, integral of 1 by 1 plus e to the power minus x. Okay, so it's just a normal algebraic thing what I'm doing here, 1 by e power x dx. Take the LCM carefully. So this one will be turning out as e power x is your LCM, e power x plus 1. So integral of 1 by this nonsense, just a flip there, e power x by e power x plus 1 dx. And now understand the question. Now, when I consider denominator to be t, let e power x plus 1 equal to t. I say differentiating this, what do we get? E power x differentiation is e power x only. E power x dx is nothing but dt. Right. So that is what you find in the numerator there. Finish. Close the answer, isn't it? So this is very simple. This is dt by t, which is nothing but log mod t plus c, which is nothing but log mod t. What is t? T is nothing but your, what did we consider? E power x plus 1 plus c. Finish. Right. Now for the next question, integral of, this is a constant value to the power x. Now tell me what is integral of a to the power x dx. So integration of a power x dx will be always a power x by log a base e. Remember this, isn't it? A power x dx integration is a power x log a base e, right? So here, and the differentiation of a power x, what is it? A power x log a base e is the differentiation of a power x. So based on these two facts is what we are going to solve this problem. Right, now coming here, 5 to the power 5 to the power 5 to the power x, so big, huge value is given. So consider the bigger one to be your t. So let 5 to the power 5 to the power 5 to the power x equal to t. Now differentiate carefully. Think that this is all your a to the power x. So which is nothing but a power x log a. Here your a is nothing but like your 5 and x is nothing but your 5 to the power 5 to the power x. So its differentiation will be what? A to the power x log a. So 5 to the power x, very carefully do it. Okay, now so 5 is your a. So a to the power x, in the sense it is the same 5 to the power 5 to the power 5 to the power x. A to the power x into log a. Right. Again, we need to differentiate this part, isn't it? So differentiation of that part is again 5 to the power 5 to the power x into another log 5, isn't it? Applying in the same way. Again, in differentiation of that part, which is 5 power x, which is again 5 to the power x log 5. Clear? It's a chain. So chain differentiation is what we have done. So finally, what did we end up with? So this is nothing but 5 to the power 5 to the power 5 to the power x, 5 to the power 5 to the power x, and 5 to the power x with log 5 to the whole cube dx equal to dt. Okay, now observe the question turned out very simple. From here till here, dx is nothing but your 1 by log 5 whole cube dt with an integral. That's it, finish, isn't it? So because this is just a constant value, so you can just replace it. So this is nothing but 1 by log 5 whole cube into t plus c. But what is the t? T is nothing but 5 to the power 5 to the power 5 to the power x plus c. There ends your question there. Very simple. Just revisit the question again, rewind it back a few minutes and check it carefully once again. All right, now look at the question, integration of cot x, root cot x by sin x cos x dx. Right, for this question, so whenever you have a cot x, the suitable function for the replacement will be your cot x. See, observe the trigonometric identities, that is sin square theta plus cos square theta is 1. 1 plus tan square theta is secant square theta. 1 plus cot square theta is cosecant square theta, isn't it? So for see, as we know that 1 plus cot square theta is cosecant square theta, who will be the friend of cot x? Who can save cot x? Cosecant only will be saving him, isn't it? So the comfortable function what we can replace with cot x will be, you need to include cosecant square x in our question. So you just multiply and divide with our savior of cot x, that is nothing but, yeah, so I am just rewriting the question. So this is nothing but root cot x by sin x cos x dx. But what are we multiplying and dividing with? That is our cosecant square x. And here also cosecant x into cosecant x is what I am writing. Cosecant square x only, but 2 times I am writing. Reason being, one sin x and cosecant x will be merging and they will be dissolving there. Right. So what am I left with now? So now here I need to take the suitable substitution. Let x equal to cot x. Now what is your dx equal to cot x differentiation? That is minus cosecant square x dx, which we already have there. See, observe, cosecant square x dx is nothing but, let me take theta here. I have taken x there. Okay, okay. So let me consider some t here. T equal to cot x. Okay, dt. Right. Fine. So this is nothing but minus dt. And this you have a root t with minus dt upon, what is your denominator? Anyhow, sin x and cosecant x becomes 1. So what is cos x into cosecant x? Remaining are these two, isn't it? So what is cos x into cosecant x, which is nothing but cos x by sin x, which is nothing but your cot x. So you have cot x in the sense t there. So t in the denominator. Is that clear? So nothing but minus integral of 1 by root t dt. From here, I think you can do it. Okay. So what is 1 by root t? Which is nothing but t to the power, see, minus integral of t to the power minus 1 by 2 dt. So obviously x to the power n integration x to the power n plus 1 by n plus 1. So this is t to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. Now this is nothing but root t there, and here also minus 1 by 2 plus 1, 1 by 2 taken to the numerator, minus 2 plus c. That t is what you just replace back again in your question, which I'm not doing, which you have to continue solve it. Right, now slowly pacing the difficulty level up. Now integral of sine 3x by sine x into cos x dx. This is what our question is now. Right. Now, what do we have to think? Whenever you have, so what are all the formulae that I can apply? I'm just writing here, right? So what is sine 3 theta? Because I have a sine 3x, sine 3 theta is what? 3 sine theta minus 4 sine cube theta. Okay, I can write that. And I have a cos 4x. It's a multiple angle of cos, isn't it? So what is the multiple angle of cos? I can also write that. So cos 2 theta. Cos 2, see, instead of writing this cos 2 theta, I would prefer 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. These are all the 3 things which are important for our question. Right. So now let us start with the question. So this is integral of sine 3x. So what is sine 3x? I am just replacing, that is nothing but 3 sine x minus 4 sine cube x in my numerator by my denominator. I can just take a sine x common, isn't it? So if I remove a 3 sine x common, I am left with, oh yeah, just a minute. Where is the bracket? I'm not supposed to take a bracket there, isn't it? So this is nothing but 3 sine x minus 4 sine cube x. So what do I take common? I just take a sine x common. I am left with 3 minus 4 sine square x by sine x into cos 4x dx, right? So I can just remove these two. All right. So I can split the numerator, isn't it? So 3 by cos 4x minus 4 times integral of sine square x by cos 4x dx. Right. So sine square x is what we have. Cos 4x is what we have. All right. Now, what is sine square x from here? So is my sine square x taken as 1 minus cos 2 theta by 2? Right? Sine square x is nothing but 1 minus cos 2 theta by 2. How about what is cos 4 theta? If I write cos 4 theta, see, I also know that cos 2 theta is 2 cos square theta minus 1. See, as there is a huge gap in between x and 4x, I can increase my x to 2x, decrease my 4x to 2x, isn't it? So that those two remain the same there. So increasing my x multiple to 2x, how do I do it? I know that 1 plus, 1 minus cos 2 theta is 2 sine square theta. Hence, 2 sine square theta is 1 minus cos 2 theta by 2. Replacement can be done there. Now, cos 4x is there, which means I have a cos 2 theta, think about it, which is 2 cos square theta minus 1. I need a cos 4 theta. So, which is nothing but 2 cos square 2 theta minus 1. Wonderful. Now, I got both of them in the same trigonometric ratio. Now, I am going to replace. This first part, I think I need not solve it any further because this is nothing but what? 3 times integral of secant 4x dx. What is secant x integration? Integral of secant x is log mod secant x plus tan x, isn't it? Log mod secant 4x plus tan 4x upon 4 plus c. Anyhow, so that first part is already done. My concentration is completely now on the second part, what I am going to do now. Second part, how do I do? Now this sine square x is what I am replacing with. So now coming here, 4 times integral of what is sine square x? 1 minus cos 2 theta by 2 into, this is nothing but 2 cos square 2 theta minus 1. All right. So what best I can do now? 4 cos 2 theta. Or else why can't we do it in the beginning itself? 3 minus 4 sine square theta దగ్గరే we will be replacing Nana. Right. So there itself we will be replacing just a small correction. Yeah, because when we tried this way, we are ending up with no result there. Okay, right. So here itself, sine square x itself, I am going to replace with 1 minus cos 2 theta by 2. Okay, so observe carefully, 3 minus 4 times sine square x is 1 minus cos 2x by 2 whole divided by cos 4x, right? This gets cancelled. Now 3 minus 2, which is nothing but 1, minus of minus plus 2 cos 2x, isn't it? Oh, all right. Now we will be able to get by 4x. Here also by cos 4x. Right. So this part integral, first part I am not solving. Second part itself I am concentrating on. First part is what anyhow we have just now done. So 1 by cos is nothing but secant x. Secant x integration is log mod secant x plus tan x. That part you do it. Right. I am concentrating on 2 times integral cos 2x by cos 4x. Right. Now, what is this cos 4x, which is nothing but 2 cos square 2x minus 1. So, 2 integral of 2 cos 2x by replacing this as cos theta is better or sin theta is better. Now, that's a major choice now, isn't it? Because cos 2 theta, I have another option also, which is 1 minus 2 sine square theta. This will be the best choice. Reason being, I have cos in the numerator there, isn't it? So cos 4 theta will become how much? Now 1 minus 2 sine square 2 theta. Right. So cos 4 theta is 1 minus 2 sine square 2x dx. All right. Right. Now I can replace with a substitution that let sine 2x equal to t. Right. When sine 2x equal to t, sine 2x differentiation is cos 2x with one more 2 dx equal to dt. So cos 2x dt is how much? 1 by 2 dt. So just replace there now. Right. So 2 times into 1 by 2 dt by 1 minus, what is this? 2 times t square, right? So 1 minus 2t square now. So does it look like take a 2 common out? So that is nothing but 1 by 2. These two anyhow gets cancelled. So if I remove 2 common, 1 by 1 minus 2 minus t square dt. Right. Is this 1 by root 2 whole square? Right. So 1 by a square minus x square integration now. So what is 1 by a square minus x square? Integral of this. Do you remember that? 1 by a square minus x square, which is nothing but, yeah, 1 by 2a log mod a minus x, no, x plus a by x minus a, isn't it? So that part is what you can continue from there, but replace your t with the suitable substitutions at the final stage, which I am not doing, which you need to continue. Done? So did you all understand what we have done here? So first thing what we have done, sine 3x is replaced it like 3 sine x minus 4 sine cube x. Next, I have removed sine x common, cancelled out. So 3 minus 4 sine square x. That sine square x also can be replaced with 1 minus cos 2x by 2. So that is what done, and we ended up with 1 by cos 4x and cos 2x by cos 4x. 1 by cos is always secant, which has no problem at all. Problem arises with cos 2x by cos 4x. Both are in the different angles there. One is 2x and one is 4x. How to get them to the same angles? 4x can be reduced to 2 angles, 2 theta, isn't it? From cos 2 theta formula. What is cos 2 theta? Either you can go with 1 minus 2 sine square theta or 2 cos square theta minus 1. But the better choice is 1 minus 2 sine square theta, because if I take a substitution this sine 2x as t, sine 2x differentiation is cos 2x. So cos 2x is what I find in my numerator. Hence, I would like to go with that. Clear? So if you take 2 cos square x minus 1, what happens? So 2 cos square x minus 1, if you take cos 2x, if you take it as t, in differentiation of cos 2x is sine 2x, which we don't have there. So based on the values, what we have is what we need to choose our value. Clear? So from there, I think 1 by a square minus x square form, you'll be knowing that. That will be a better idea. Right. Next. Right. Now coming for the 11th question, integral of dx by sine x plus root 3 cos x. Right. So do you observe A cos theta plus B sin theta form? Whenever you find A sin theta plus B cos theta or A cos theta plus B sin theta form, always go for multiply and divide by under root of A square plus B square to get it to a single trigonometric ratio, isn't it? Because your sin x and cos x are two different things, right? So two different ratios, we cannot solve it. So hence we can bring them to single by just multiplying and dividing with under root of a square plus b square, which is nothing but under root of 1 plus root 3 square, that is 2. So what I am going to do for this question, 1 by 2, 1 by 2, and here it is 2, 2 into 1 by 2. Okay. Now, how does your denominator change? So this is nothing but I can replace this with a sine 30 and this with a cos 30, isn't it? Or sin A cos B, cos A sin B is what we will take. Okay, na? So, right, sin A cos B in the sense this is cos 60 and this is cos 30, sorry. Oh, wait a minute, wait a minute. Right. So, this will be cos 60, right? Right. So, in this, sin x cos 60 plus cos x and sine 60, because root 3 by 2 is considered that way. So sin A cos B plus cos A sin B, which is nothing but sin A plus B is what I'm going with. So 1 by 2 times cosecant, isn't it? This is nothing but integral of cosecant x plus 60, or this is nothing but pi by 3 dx. So what is integration of cosecant x? Cosecant x integral is log mod cosecant x minus cot x, isn't it? So cosecant x plus pi by 3 cosecant x minus cot x, that is cot x plus pi by 3 with a half log so and so, plus c will be your answer, right? Understood? Continue with the next question. So that is your 12th one. Now integral of dx by x square plus 3x minus 10. Now, how do we go about this one? So I hope everyone knows completing square method, isn't it? X square minus 3x minus 10. Whenever you have your denominators to be in quadratic, splitting the middle, not the splitting the middle term, it's like completing square method is what you need to do it and get it to the form of a square minus x square or x square minus a square form is what we need to get, right? Now coming here, x square plus 3x minus 10 is the given question. So there are the steps to be followed. Select your x coefficient, divide by 2, square it, add and subtract, isn't it? So what is your x coefficient? 3, divide by 2, square it, add and subtract. So observe carefully, x square plus 3x plus 3 by 2 whole square minus 3 by 2 whole square minus 10. Right, so these three together, that will be a square plus b square plus 2ab, which is nothing but a plus b the whole square plus, here you have your denominator to be 4, and that is your minus 9 minus 10, which is minus 19 by 4 is what you get, which is nothing but, yeah. Right, so x plus 3 by 2 whole square minus root 19 by 2 whole square is what you have. Right, so now this is of the form 1 by under root x square plus a square, which is nothing but x square minus a square, isn't it? Which is nothing but 1 by 2a log mod x minus a by x plus a. Just you replace your x by x plus 3 by 2 and replace your a by root 19 by 2. That is enough for the question. Similar question is what you can try. Few other questions is what we have. Those questions also you may try. I'll be giving you as homework. See that you complete them as homework. So these are your 13, 14, 15 questions. You may do it for your homework. So try them. It's the same way. Completing square method is what you need to do. Apply under root 1 by under root a square minus x square or 1 by under root x square minus a square. That way you need to proceed. Okay. Right. Now coming here, 3 power x by under root of 16 plus 9 power x dx is our question. Right. So wherever you find 3 power x and 9 power x, immediate thing what should strike our brain is let 3 power x equal to how much? T. What do you get? What is your 9 power x? Which is nothing but t square, isn't it? Right. So now how do you rewrite the question? When 3 power x is t, a power x dx, isn't it? So 3 power x log 3 dx equal to dt. So what is 3 power x dx, which is nothing but 1 by log 3 dt, which I am replacing here. So 1 by log 3, anyhow, a constant, I am taking it out. So that is 1 by log 3. 3 power x dx is dt by under root of 16 plus 9 power x. So that is 16 plus what is 9 power x, which is nothing but t square, right? Now, which form do you find here? Integral of 1 by under root of a square plus x square dx, isn't it? What is it? That is nothing but sine inverse x by a. Sorry, sine h inverse, isn't it? So sine h inverse x by a plus c. So from here, what do we end up with? So 1 by log 3 into sine h inverse, that is a t by 4 plus c. That t is what you can just replace it back again, hence your answer. Right, now coming for the question number 17 there. So whenever you find this form x square plus 1 or x square minus 1 in the numerators, understand the pattern of the questions first, right? So wherever you find x square plus 1 or x square minus 1 in the numerators with the denominators in the form of x power 4 plus 1 and this way. So then what you need to do is, the first thing what you need to strike in your brain is multiply, or else you do one thing, divide by x square is a better option first. Okay, now. So just divide by x square both in the numerator and denominator. Now rewrite the question. When you're dividing every term by x square, just divide every term by x square. So is it 1 plus 1 by x square upon x square plus 1 by x square dx. Okay. Now this is what we have. Now remember one thing. Whenever you have 1 plus x square pattern here, please take the substitution to be x minus 1 by x equal to t. Okay. I'll tell you why. Because when x minus 1 by x equal to t, what is differentiation here? This is 1. 1 by x differentiation is minus 1 by x square. So minus of minus plus 1 by x square dx equal to dt. You automatically find this in your numerator. Did you understand? Here. But here, if you observe, here also observe the 18th question, both of them simultaneously I'm doing just to differentiate between the two questions. So here also, if I divide by x square, what do I end up with? That is nothing but 1 minus 1 by x square upon x square plus 1 by x square dx. Okay. So here, what is the substitution that I can do? Think about it. Let whenever you have 1 minus 1 by x square, substitute your x plus 1 by x as t and proceed, because differentiation of x is 1, differentiation of 1 by x is minus 1 by x square dx equal to dt, which you automatically find this one in your numerator for the substitution. Clear with that? Right, let's go ahead. Now this is nothing but 1 by 1 plus x square dx equal to dt. Hence, it is dt by, now what about x square plus 1 by x square? What shall I substitute? Observe from there, squaring on both sides, a square plus b square minus 2ab, which is nothing but equal to t square. These both get cancelled. So what is x square plus 1 by x square? That is nothing but your t square plus 2. Just place it there. All right. So this is your t square plus 2. Now integral of, now can I just rewrite this like 1 by t square plus root 2 square dt? Isn't it? So 1 by x square plus a square again. 1 by x square plus a square is what? 1 by 2a log x plus a of x plus a by x minus a is what you will be getting. Clear? So that part from here, you can do it. Once we get it to the integrable form, just substituting your proper substitution there is the best option. You can continue doing that. Now observe here. So here also 1 minus x square dx equal to dt. Fine. But what shall I replace here? Also x square plus 1 by x square plus 2x into 1 by x, which is nothing but t square. Hence, what is x square plus 1 by x square? That is t square minus 2. It is your t square minus 2. Right. Again, root 2 square is what you consider, because x square minus a square form is what we need, isn't it? So integral of 1 by x square minus a square is again 1 by 2a log x minus a by x plus a plus c. That t is what you will be replacing back again, and check it in your options. All right. Yeah, coming for this question, a slightly different question, not difficult. Right. Now we need to understand the pattern behind x power 6 plus 1. How do I write x power 6 plus 1? That is my x square whole cube plus 1 square. No problem, right? Because a cube plus b cube. Now tell me, what is a cube plus b cube identity? In its factorized form, that is a plus b of a square plus b square minus ab. Isn't it? A cube plus b cube always starts with a plus b, and a square plus b square minus ab there. So just apply a cube plus b cube. That is your a plus b of a square in the sense x power 4 plus b square in the sense 1 minus ab, that is x square. Clear? Here your a is your x square, b is your 1. Treat them properly. Right. Now you have x power 4. This denominator, when I have split it, I got it to the form of x square plus 1 into x power 4 plus 1 minus x square. Now observe your numerator. Wonderful thing what you find there, isn't it? See, you have x power 4 plus 1 in the numerator, but something is missing. What is that missing? Missing is your minus x square. So I am just rewriting the question, x power 4 plus 1 by x square plus 1 into x square plus 1 minus x square dx is already there. Whatever I need minus x square. That I will take minus x square with a plus x square and proceed. Is the question clear now? Now observe these three as one set. Split the integral. X power 4 plus 1 minus x square by x square plus 1 into x power 4 plus 1 minus x square plus integral of x square by x square by all this. I will just write it like, okay, fine, x square plus 1 into x square plus 1 minus x square. All right, this is what I have. Now there are terms which are getting cancelled. Ting, ting, got cancelled, isn't it? Now what is 1 by 1 plus x square dx? 1 by 1 plus x square is nothing but your tan inverse x dx. That part is already done. Right. Now observe carefully. This one, if I keep it in this way, it is not going to fetch me at all. Isn't it? This is power 4 nana. Right. So what I'm going to do is I'm rewriting it like x square by 1 plus x power 6 dx only is what I will write. And I will be changing x power 6 like x cube whole square. Problem ledga? Right? It is my x cube whole square. Now when I consider let x cube equal to t, 3x square dx will become dt. Right? So what is x square dx? Now just replace in your question. Now this is all the rough part what we have done. X square dx is nothing but 1 by 3 dt by 1 plus what is x power 6? T square, isn't it? Because x cube is t. Now 1 by 1 plus t square again, 1 by 3 tan inverse t plus c. And that t is what you replace again, you will be getting it. Understood? Clear at that question? Right. Yes, now the question 21 seems to be very simple, but not that easy to solve, isn't it? Right. So root tan x, you just don't get any other thought. Right. So what we have to do is let us try to free our tan x from the root. And how do I do it? Let tan x equal to, let me consider some t square. Okay. So if I consider tan x equal to t square, what is its differentiation? Tan x is secant square x dx equal to 2t dt. This is what we have. Okay. Now what is secant square x? 1 plus tan square x, right? Secant square x is 1 plus tan square x. So 1 plus tan square x. And 80 secant, see, observe here, 1 plus tan square x. So 1 plus tan x is already t square. So hence it is t power 4 dx, which is nothing but equal to 2t dt. Clear till this point? Right. Now I am going to replace all this in my question. So root tan x ante root t square, which is t, into what is dx? Dx is 2t by 1 plus t power 4 dt. That is what I am replacing. Dx is 2t by 1 plus t power 4 dt. So finally, what did I get? Integral of 2t square in the numerator. What is this? 2t square. by 1 plus t power 4. Now with this also, I actually cannot do anything. So what I need to think is a 2t square is a t square plus t square. Problem ledga, right? So t square plus t square. Now some change. Can I just take plus 1 and a minus 1? Plus 1 and minus 1 is what I have considered by 1 plus t power 4, and by 1 plus t power 4 is what I have rearranged them. dt here, dt there also. Now, which form is the first part looking like? If I divide by t square, see what problem we have done earlier. T square plus 1 is there, and 1 by 1 plus t power 4 is there. Hence, what do we need to do? Divide each and every term by t square. You will end up with 1 plus 1 by t square by 1 by t square plus t square dt. Now, what is a suitable replacement here? Let 1 minus 1 by t equal to some y you consider. Then t minus 1 by t, sorry. T minus 1 by t equal to y if you consider. T differentiation is 1 plus 1 by t square dt, which is nothing but equal to dy. That replacement is what needed. Again, squaring on both sides. T square plus 1 by t square minus 2 equal to y square. Right. So now rewrite the first part. See, I will consider this as my first part I1 and that as my second part I2. So I1 only is what I am solving now. Now my numerator is 1 plus 1 by t square dt, which is nothing but equal to dy upon y square plus 2, which I will write it like y square plus root 2 whole square. Reason enti? 1 by a square plus x square. Again, I will be taking it like, what is it? 1 by a square plus x square. That is tan inverse x by a, isn't it? So 1 by a tan inverse x by a. So that part you can do it from there. So this can be done. Now, what about I2? I2 is nothing but integral of t square minus 1 by 1 plus t power 4 dt. Here also doing in the same technique. What is it? Divide by t square. 1 minus 1 by t square by 1 by t square plus t square dt. Here also you'll do the same thing. What is it? What is the substitution that I'm going to go with? T plus 1 by t equal to some you consider, because you have 1 minus 1 by t square. In its differential form, you need to get it. Ante t plus 1 by t equal to ui undal. Ante 1 minus 1 by t square dt equal to du. Carefully substitute 1 minus t square dt, which is nothing but equal to du by, what is this? Again, squaring on both sides here. T square plus 1 by t square plus 2 equal to u square. Hence, you can consider here to be u square minus 2. All right. Can be written like root 2 whole square. So now it looks like 1 by x square minus. So welcome to the next set of integration problems based on few important formulas what we are going to solve today. So 1, 2, 3, and 4. So I have given you 4 important formulae which gives us best answers. So all these formulae are, we have actually derived these formulae and kept them ready for our further future use, right? Suppose if you consider e power f of x here. So the second one, if you observe, the answer of integration of e power x into f of x plus f dash of x dx. So if you observe this part, e power x into f of x plus c is there. So integration of something is a value in the sense, if I take the differentiation of this, I need to get back the result. Let us check e power x f of x. If I differentiate this, so it is first function and second function. So first function into integral of, into differentiation of second. Next plus second function into differentiation of the first. So I can just take e power x common. I got f of x plus f dash of x. right? So did we manage to get it back again? So e power x into f of x plus f dash of x. Clear? So all these functions are pre-derived formulae which we are going to use in our further questions. So every question what you observe, see, suppose if this is when you're talking about x into f dash of x, so let us derive what is this x into f dash of x into f of x. If I'm deriving, if I'm taking its derivative, so what is it? First into uv formula, uv dash plus uv dash, isn't it? So uv dash x into f dash of x plus f of x into differentiation of x is 1. So which means it is nothing but f of x plus x into f dash of x. So did you get back the same back again? Right? So similarly, if you do the one first and fourth also, you get back the same formulae. Clear? So all these are the four major important formulae what we are going to use in our further questions. Okay. So now let us go with the first question of today's class. So if you observe the question 22nd one, integral 1 plus x minus 1 by x times e power x plus 1 by x dx, right? So what we are going to take is, suppose, let it be whatever be irritating factor, let me consider. So let us consider that to be some t, okay? So let e power x plus 1 by x equal to t. If I consider, what do I get? Let us just check, okay? So e power x, it is nothing but e power x only. That means e power x plus 1 by x into, what is the differentiation of x plus 1 by x? 1 minus 1 by x square dx, which is nothing but equal to dt. Right. Now, did we get it that form there? 1 plus x minus 1 by x is what you observe. In these two, if you take x common, what do we get? So integral of 1 plus x, if I take common from these both, 1 minus 1 by x square into e power x plus 1 by x dx is what I have, isn't it? So now let me expand it first with that and this one with that, right? So that is e power x plus 1 by x plus x into 1 minus 1 by x square into e power x plus 1 by x dx. This is what I have now. Right? Now observe very carefully. If I consider this as f of x, that is this one, right? If this is f of x, is this nothing but the f dash of x? Isn't it? So e power x plus 1 by x into 1 plus 1 by x square all together considered as f dash of x. Isn't it? So plus this x remains the same. Now tell me what is integration of f of x plus x into f dash of x dx according to the formula which we have just now learned. What is it? Nothing but x into f of x plus c, isn't it? So which means x into, what is f of x? F of x is e to the power x plus 1 by x plus c. That's it. That's your answer there. Right? Understood? So whatever be the irritating factor there, e power x plus 1 by x, let us consider that to be t and go for the differentiation of that. So e power x plus 1 by x into 1 minus 1 by x square dx equal to dt. So that part is what we need to attain. So in order to attain this, what I have done, from these both, I have taken x common. Then I got 1 minus 1 by x square. Clear? So 1 plus x into 1 minus x square into e to the power x plus 1 by x dx is what I have. Now, we have got two terms here. First into e power x plus 1 by x. Second into e power x plus 1 by x. Now you just consider, treat one of them to be f of x. The other will automatically turn out to be your f dash of x dx, right? And with an x there. So f of x plus x, f dash of x integration. The formula which we have already derived and kept it aside, that is nothing but x into f of x plus c. So that is what, just the substitution there. That's it. Well, another most beautiful problem. So if you observe, x plus sine x by 1 plus cos x dx is there. See, generally, if you observe x plus sine x, what is its differentiation? That is 1 plus sine x differentiation is cos x dx, isn't it? So try to understand your numerator is f of x, your numerator is f of x, and your denominator is f dash of x. So we don't have any such form. If at all we have our denominator is f dash of x, and if your numerator is f dash of x and denominator is f of x, then integration of this is nothing but log mod f of x plus c. That is what I can substitute. But for this question, it is not applicable, right? So apply a different strategy here. So apply some trigonometry rules there. So what is 1 plus cos theta? Wherever you find 1 plus cos theta, immediately 1 plus cos 2 theta, which is nothing but 2 cos square theta. So hence, what is 1 plus cos x, which is nothing but 2 cos square x by 2 is what you are replacing. And the numerator, sine 2 theta, which is nothing but 2 sine theta cos theta. Hence, what is sine x only? Half angles is what you have to take there. So 2 sine x by 2 cos x by 2. So let us see what happens here after this substitution. So this is now x plus sine x is 2 sine x by 2 cos x by 2 upon now 1 plus just a minute, right? What is 1 plus cos x, which is nothing but directly 2 cos square x by 2 dx. All right, this is what we have. Now let us split the numerator, x by the denominator, x by this whole denominator, plus 2 sine x by 2 cos x by 2 by the whole denominator, right? So x by 2 cos square x by 2 plus 2 sine x by 2 cos x by 2 upon 2 cos square x by 2. So terms are getting cancelled here. So 1 cos x by 2 gets cancelled. You are left with 1 by 2 integral of so can I take 1 by cos square to be secant square x by 2 into x into secant square x by 2 plus 2 also gets cancelled. Sin x by 2 by cos x by 2 will be tan x by 2 dx. And now you find a beautiful relation. What is that? Observe what is f of x and what is f dash of x. So consider your f of x to be your tan x by 2. Immediately, what is f dash of x? F dash of x is nothing but secant square x by 2 into 1 by 2, isn't it? Oh yeah, I think I've written wrong here. 1 by 2 has to be inside. I cannot take it outside there, isn't it? Yeah. Right. So this is nothing but 1 by 2 into, yes, so 1 by 2 secant square x by 2. So integral of x into, this is f dash of x plus your tan x by 2 is your f of x dx. Again, the same rule. What is it? Integral of f of x plus x f dash of x is nothing but, anyone guesses? So x into f of x plus c. That's it. So x into, what is your f of x? Nothing but your tan x by 2 plus c will be your final answer there, right? So applicability of all the derived formula is what we are going to do in this video. Yes, another beautiful question. That is 1 plus sine x by 1 plus cos x. So obviously 1 plus cos 2 theta, which is nothing but 2 cos square theta. Hence, what is 1 plus cos theta? This is nothing but 2 cos square theta by 2. Now, coming for 1 plus sine x. So how do you write this 1 plus sine x? So 1 plus sine x is nothing but 2 sine x by 2 cos x by 2 and with your e power x dx, right? And now e power x times, now what is it? Again, it's the same thing what we can do here, isn't it? So 1 by 2 secant square x by 2 plus 2 and 2 gets cancelled, 1 cos x by 2 gets cancelled, just like the previous question. That is your tan x by 2. Now observe the same thing, isn't it? This is your f of x. This becomes your f dash of x. But the formula now is e power x into f dash of x, f of x plus f dash of x integration dx, which is nothing but e power x, f of x plus c. So final answer is e power x into f of x is nothing but tan x by 2 plus c. Clear at that? Right, for this question, we have sine log x plus cos log x dx. This is what we are going to integrate. And here the irritating factor for us here is now log x equal to t. So let us consider log x equal to t. Now tell me what is x equal to e power t, isn't it? Now differentiate this. So dx equal to e power t dt. So this is what we have, right? Fine. Now just replace. So this is nothing but sine log x is there, right? Right. So log x is nothing but sine t plus cos t. Now dx. What is dx? E power t dt. This is e power t dt. Now when you observe, is this nothing but e power x into f of x plus f dash of x, isn't it? So when this is your f of x, is this automatically turning out to be f dash of x, right? So what is e power x into f of x plus f dash of x dx integration, it is nothing but e power x into f of x plus c. So please, every time keep writing the formula so that you remember it well, isn't it? So now this is nothing but e power t. Now we are using t, right, isn't it? E power t into sine t plus c. But just resubstituting back your t is very important, right? So e power log x into sine t is nothing but log x plus c. Right, that's it. That's your 25th question. All right. Now, another question is what I'm giving you. So, integral x e power x by 1 plus x whole square dx. This is what we have. Right, now try to understand x e power x by 1 plus x whole square. Right. So looking at this, we don't get any thought unless we do some manipulation for our question, isn't it? So x by 1 plus x whole square and e power x is there. I have written a gap there. And in order to fill this gap, I have, see, observe here 1 plus x. So maybe I can try it with plus 1 and minus 1. Let us think about it. Have a thought there. X plus 1 is one set and 1 is the other set. I am just splitting that. So x plus 1 by 1 plus x whole square minus 1 by 1 plus x the whole square times the whole into e power x dx is what I have considered. So terms are getting cancelled. 1 plus x with 1 plus x gets cancelled. Now I have 1 by 1 plus x minus 1 by 1 plus x the whole square times e power x dx. Now, do you find the formula that we can see here, which is your f of x? Does it look like your f of x and this becomes your f dash of x automatically? Isn't it? So if your f of x is 1 by x, obviously f dash of x will be how much? 1 by minus 1 by x square, isn't it? So 1 by 1 plus x and minus 1 by 1 plus x square, you find it there very beautiful way, right? Hence, this is nothing but what? E power x into f of x plus c. That's it. So e power x into what is our f of x? F of x is 1 plus x plus c. Finished. There ends your answer. Now coming for this question, 3 minus x square by 1 minus x whole square e power x dx. So here also some kind of manipulation is what I need to do. And what is that manipulation? See, I want 1 minus x. So can I split it like 2 minus 1? 3, 2 plus 1. So 2 plus 1 can be written for 3. Right, now when I'm splitting, is it nothing but 2 by 1 minus x the whole square plus 1 minus x square by 1 minus x the whole square. The whole multiplied by e power x dx is what I'm doing here. Okay. Now, are there the terms which are getting cancelled? Yes, because 1 minus x of 1 plus x is what I can find. 1 minus x may get cancelled here. So I am left with 2 by 1 minus x the whole square plus 1 plus x by 1 minus x multiplied by e power x dx. Okay. Now, this might be of the form e power x into f of x plus f dash of x, which I don't know. I need to check that. So in these two, which one could be our f of x? See, if this is your f of x, let us just check whether f dash of x is the required output there or not. Let me consider f of x is 1 plus x by 1 minus x. So this is u by v, isn't it? So what is f dash of x? V square in the denominator, that is 1 minus x whole square, right? Into, now numerator will be v into u dash. U dash is nothing but 1 minus u into v dash. V dash is minus 1. So just expand your numerator, 1 minus x minus of minus, that is plus 1 plus x. So these both getting cancelled. You got 2 by 1 minus x whole square. Wonderful factor. This is your f dash of x, isn't it? Now the question has automatically turned out to be e power x into f of x plus f dash of x, which is nothing but e power x into f of x. So now final answer is e power x into f of x is 1 plus x by 1 minus x plus c. There ends your question. Done? Right. Now, what has to be done here for such questions? So the thought is like, let us start with log x equal to t, which means x equal to e power t. Okay. So obviously dx equal to e power t dt. So this part will be replaced. Now integral of log x is a t minus 1 by, we've got t square plus 1 the whole square times e power t dt. Right. So what shall we do now? Let me expand your numerator there. Right. So which is, oh, here it's not writing. Yeah. T square plus 1 minus 2t by t square plus 1 the whole square, isn't it? By t square plus 1 the whole square, the whole multiplied by e power t dt. Now just try to observe what I'm doing. I'm splitting this by the denominator minus 2 this by the denominator. Okay now. So t square plus 1 by t square plus 1 the whole square minus 2t by t square plus 1 the whole square whole multiplied by e power t dt is what we have. All right. So anyhow, 1 t square plus 1 will be getting cancelled there. Right. So we just have to check whether, if, I don't know whether it is right or wrong, but let us check. So if at all my f of x is 1 by t square plus 1, if at all my f of x is 1 by t square plus 1, right, what could be f dash of x? What could be f dash of x? So obviously 1 by x form is nothing but minus 1 by x square. So 1 by x in differentiation is minus 1 by x square, that is t square plus 1 the whole square. Again differentiation of t square, that is 2t. So finally you found this to be your f of x, and plus the other one is your f dash of x into, or f of t you may consider, f of t plus f dash of t into e power t dt, which is nothing but e power t into f of x or f of t, which is nothing but how much? That is 1 by 1 plus t square plus c, right? So now e power t, resubstitute your t, e power log x into 1 by 1 plus log x whole square plus c will be your final answer there. Yes, going for the next question. Even here, let us consider log x equal to t, which means x equal to e power t. Obviously, dx equal to e power t dt is what we have. So rewriting the question, that is log t plus 1 by log x is nothing but t square and the whole multiplied by e power t dt is what we have. All right. Log t. All right. So if I consider f of x to be log t, or f of t to be log t, what will be our f dash of t? 1 by t is what we have. But that is not showing our 1 by t square, isn't it? So maybe I need to go with f double dash of t, isn't it? So f double dash of t is minus 1 by t square. Wonderful, we got it, isn't it? So from there till here, the journey step. So this is my f of t plus f double dash of t. Got it? But you have a minus difference there, isn't it? So minus of, right. So I need to include a minus there. It's a minus of minus, isn't it? So minus, so you can take minus of minus 1 by t square. Your minus 1 by t square is your f double dash of t. Clear? So times your e power t dt. Now what is this formula? Do you remember? E power t, we have a formula, integral of e power t or e power x, f of x minus f double dash of x dx is nothing but e power x into f of x minus f dash of x plus c is what we have. That is the formula that we are using, minus f dash of x. Yes, so applying that formula here, that is nothing but e power t into f of t minus f dash of t plus c. Now, what's your final answer? E power t. T is nothing but log x. So, e power log x times. So, f of t. What is our f of t? Log t. Isn't it? So, f of t minus f dash of t. So, log t minus f dash of t is 1 by t plus c. Please do not leave it in t's. So, this is nothing but log of t is nothing but again log x minus 1 by log x plus c e power log x multiplied. This is your final answer there. So usage of the formula is what given here. Yes, now coming for a most beautiful question. So this is an IPE question, definitely one page, a 7 marks definite question kind of question is what we are going to solve just like this within a minute. Right. So this is the trick what we are using here. So observe here carefully. Whenever you have a cos x plus b sin x and c cos x plus d sin x, it's a linear combination of cos x and sin x is what we have in both numerator and denominator. Then, so how do you have to remember this is follow the alphabetical order, isn't it? So what is the alphabetical order? A, B, C and all, right? So C first, cos first, sin next. If it is given in a jumbled way, please do arrange it in cos plus sin pattern only, right? After arranging this, so what do we do? Observe how I am writing the answer for this. Just a minute. Yeah. So observe here clearly A and C, AC with B and D. Just a net problem. Hold on, please. So observe what we are going to do. So it is direct one, AC with BD first. So first of all, it is AC with BD combination, what I am doing. So AC plus BD by denominator is my C square plus D square times X plus now I am going the cross way, that is AD with BC. Clear? So AD minus BC. See, when I am taking the direct thing, AC, direct product is AC plus BD I have considered. Now, when I am taking the cross product, AD minus BC is what I am considering by C square plus D square. This times log of the denominator. Denominator is your C cos x plus D sin x plus C. This is what your formula is. See, generally for this formula, for this question, what we do in the IP level, so we will be going with A times this value, A times the denominator plus B times the differentiation of the denominator plus C is what we consider, and then we apply comparing the terms on left hand side and right hand side. All this stuff will be done, and finally you get the output that is nothing but equal to one step answer here. Right. So let us solve a problem on this. So that is my 30th question. So that is integral of 2 cos x minus 3 sin x upon 3 sin x plus 2 cos x dx. So tell me, dear students, can we start the problem this way? Can I start it this way? Think about it. I said one point most important, alphabetical order. So cos first, then only sine. So remember this, cos first and then only sine. So your denominator is not given that way. So please do rearrange that 2 cos x minus 3 sin x upon 2 cos x plus 3 sin x dx. Now figure out what are your A, B, C, and D. Clear? So this is A, B, C, D. A, 2, B is nothing but minus 3, C is your 2, D is your 3. So what did I say? First thing is direct product, which is nothing but, what can I go with? AC plus BD. So that is 2 into 2, 4, plus minus 3 into 3, that is minus 9 upon C square plus D square. That is your 2 square plus 3 square, the whole into X. Next, plus the cross product is what I'm going to go with. 2 3s are 6 minus of minus, that is minus of minus 6 by some value in the denominator. What is that some value? Which is nothing but 2 square plus 3 square, isn't it? Which is 9 plus 4, which is 13 into the denominator as such completely, plus C is what your final output is, right? So finally, what do you write? So that is nothing but your so your final output is 4 and minus 9, that is minus 5 by 13 plus so and so values with the denominators, all those included, plus C. So this is a direct 1 or 2 steps answer is what you can get it, right? Such a wonderful formula. So please do make a note of this formula in a separate page so that you remember whenever needed, you will just look at that and see. Clear? So all this formula, you please remember very carefully. So it is just AC plus BD by C square plus D square into X along with AD minus BC times by C square plus D square times log of the denominator. Clear? So here also I did not mention the log. Oh dear. So in the final answer here, it will be a log of this value. Please change that correction, isn't it? So this will be your log of the denominator. So 12 times log denominator plus C. Right. Now this problem dx by 4 plus 5 tan x. So can I just convert my tan x to sin x by cos x, isn't it? So 1 by 4 plus 5 sin x by cos x, right? So taking their LCM by 1 here. So obviously this will turn out to be cos x is your denominator. 4 cos x plus 5 sin x. Now just 1 by the denominator is just a flip there. So hence it is cos x by 4 cos x plus 5 sin x integration dx there. Right. Now think about, do we have a sign there in the numerator? No. Hence you can take 0 into sin x for our use. No problem at all. Now apply the rule carefully. So this is 1 cos x, isn't it? So 1 into 4. 1 into 4 plus 0 into 5. That is this by c square plus d square, which is nothing but 4 square plus we have 4 plus 5 tan x, isn't it? Yeah. So that is nothing but 4 square plus 5 square in the denominator times multiplied by x. That is the first set. Plus now cross. So 1 into 5, that is 5. Plus now this is nothing but 0 into 4, that is 0. By, you can take a minus here actually. By again 4 square plus 5 square with log mod denominator. So log mod 4 cos x plus 5 sin x, isn't it? Oh, it's not writing. Plus C. So that kind of calculation is what you can complete there, isn't it? So from there, you can complete that. That is nothing but 4 by what is 4 square plus 5 square. All that calculation is what your part, you can do it. Right. So before going for the next problem, so integration by parts, I think most of you know that, isn't it? So integral of a first function into second function. So what is it? First function into integral of second minus integral of derivative of first into integral of second is what the formula is. Right. So now the 32nd question is based on integral of x square sine 2x dx. Right. So in this, so generally we will be going with the order is ILATE. So it's not that you need to strictly follow this pattern only, but if at all you follow this, it would be a better option because the second function what we are selecting should be an integrable function easily. So that kind of integration is what we are going to go with, right? So what do we get here? So x square into, so I am considering, so highlight in the sense algebraic will be my first and the trigonometric will be my second function, right? So this is my first function and that is my second function, right? So if I apply this approach, so what is it? First into integral of second. What is integral of second? Sine 2x integral is minus cos 2x by 2. So first into integral of second minus integral of derivative of first into integral of second. This is what I have now. My 2 and 2 gets cancelled. So this is nothing but minus x square cos 2x by 2 minus of minus plus integral. Now I am left with again x cos 2x. Again, I have to apply integration by parts, isn't it? So now it is again, I am going with minus of minus. I have removed it, taken a plus x integral of x cos 2x. So first function into integral of second. Integral of cos 2x is how much? Sine 2x by 2. First into integral of second minus integral of derivative of first. Derivative of first in the sense 1 into integral of second, which is nothing but sine 2x by 2 dx, isn't it? So finally, what do I end up with? Minus x square cos 2x by 2 plus this is x sine 2x by 2 minus, yeah. So now again, minus of. Now observe carefully, you have a 1 by 2 there, which comes out. Now, what is integral of sine 2x? Integral of sine 2x is nothing but minus cos 2x, isn't it? Minus of minus becomes plus cos 2x by 2 plus c. So this whole long process is what we need to do to solve this problem, and the question looks quite lengthy, isn't it? So integration by parts, we have a very beautiful trick. So what is the trick to remember this is the method 1, what you generally proceed with. Method 2 is a wonderful process. So generally, tell me, differentiation is what we have learned first or integration is what we have learned first? So the process is like differentiation is what we will be learning first, isn't it? So I am just mentioning differentiation and integration in 2 rows this way. Clear? So one of these two values I am going to see. We are given two functions x square and sine 2x, right? So one of them I am going to differentiate, other I am going to integrate. Now which one to select for integration and which one to select for differentiation? So whichever will be terminating after differentiating. That means suppose if you consider sine 2x for differentiable function, then sine will be differentiating to cos and cos will be again to minus sine x and again sin x again to cos x. The process keeps on continuing, isn't it? But when you consider x square for differentiation, what happens there? X square differentiation will be 2x. So x square, its differentiation will be 2x. And 2x differentiation will be 2 into 1. And 2 differentiation will be a 0 there. Understood this? Right? So we are terminating the process here. That is how you need to select your differentiable function and integrable function here. So here I am considering my x square to be a differentiable function, going with the integrable function. Now that is my sine 2x is what I am writing here. Now do it carefully. Sine 2x integration. Integration is what I need to do for sine 2x, right? So sine 2x integration is minus cos 2x upon 2, right? Again, now cos 2x by 2 integration, that is minus 1 by 2 you already have. And cos 2x integration is nothing but sine 2x by 2, isn't it? Now finally, what is it? Sine 2x, this is nothing but minus sine 2x by 4, right? Now integral of this is minus 1 by 4 into, what is sine 2x integration? That is nothing but minus cos 2x by 2, which is finally I end up with cos 2x by 8 here. Understood? Now observe the trick what we are doing. Just go across way, x square into this, 2x into that, 2 into this, 0 into, obviously the next term I'm not writing because it is anyhow 0 into. Clear? So please mention by writing after this. So final answer is what I am writing now. So understand, x square into this cross. So that is minus x square cos 2x by 2. Next, 2x into this. That is nothing but minus 2 by 4 sine 2x. Next, 2 into this. That is nothing but 2 cos 2x by 8. Now, how about the signs? Signs is just like you take alternate positive and negative. First is a positive, next is a negative you consider. So take another minus sign with that. Another one is a positive only. Clear? So alternate from here till here. If you are going, this is positive. Clear? And if you are going this way, this should become negative, and you are going this way, this should become a positive. So alternate positives and negatives is what you consider, and look at your final option there. So minus x square cos 2x by 2, minus of minus plus sine 2x by 2 again, isn't it? Because 2 ones and 2 twos gets cancelled, plus that is your cos 2x by 4. This also getting cancelled, 2 ones, 2 twos, plus c. Did we end up with the same answer as the earlier case? Right? So method 1 and method 2, if you observe, method 2 is the best method to follow, isn't it? If it is your competitive world, what you're facing. So the mains and advanced and all these MCET questions, all these is what you are going to do with this trick, that is, select one of the functions to be your differentiable function, the other to be your integrable function. Clear? So then you can apply, other than applying the IIT procedure, a normal, regular, boring procedure, which is a little lengthy when compared to this. Clear? So selection of differentiable and integrable functions is what you need to take it carefully. And how do we do that? Whichever stops after few steps different of differentiation, select that will be your differentiable function, that is x square. So x square to x2. Next, the other one obviously is your integrable function. So steps of integration is what you do. How are you going to do it? First one, x, come the cross way. Okay, x square with cos 2x by 2, 2x with this, and minus 2x with that. The cross method is what you need to follow. Later, after multiplication and writing everything, always take alternate positives and negatives. So first is anyhow positive, next is take negative, next positive. If you have few more terms, go on proceeding with the process and write the final answer. Clear with that? Right. Beautiful process, isn't it? So this one also, other than the regular IIT process, what we are going to do, we are going to select one of the functions to be a differentiable function. The other will be, we are going to integrate. So which one I'm going to select out of x cube and sine 3x? Obviously, my x cube will be my differentiable function. Next, differentiate that. That is your 3x square. Again, differentiate. That is your 6x. Again, differentiate. That is 6, and with a 0. The whole long process is what you continue. Right. Next, integration is what I'm going to go with the sine 3x. Okay. So do it carefully, dear. Sine 3x. Now, what is its integration? That is, sine x integration is minus cos x. So minus cos 3x by 3. Next, so now you have a minus 1 by 3 with cos 3x integration. That is nothing but sine 3x by 3. Now you already have a minus sine 3x by 9, let it be. Right. Now that is your minus 1 by 9 times. What is sine 3x integration? minus cos 3x by 3 again. So that becomes your cos 3x by 27. Yes. So yeah, so this is cos 3x by 27, and finally you will be ending up with sin 3x by 81. Now what is the process? Observe come the crossway. This with this, with this, and obviously 0 into anything that you don't need to consider, isn't it? So what will be my first step? That will be x cube into minus of cos 3x by 3. So that is minus x cube into cos 3x by 3 is my first step. Next, so obviously 3x square into that is nothing but minus 3 by 9 sine 3x into x square, right? Next, 6x into that plus 6 by 27 times 6x by 27 into cos 3x, and with the other one that is 6 by 81 into sine 3x, right? And what about the signs I said? First one is positive anyhow. For the next one, you take a negative. The next one is anyhow positive there. For the next one, you take a negative, right? So finally, you cancel the terms and write it carefully. So this you will have, yeah, 2 and 9 here. And here you will be having a 2 and right, 27 plus C. So final answer is minus x cube cos 3x by 3 minus of minus plus, that is your 1 by 3 x square into sine 3x plus 2x by 9 cos 3x minus 2 by 27 sine 3x plus C will be your final answer. Isn't it easy? Doing the same problem using a lengthy eyelid procedure is really heartbreaking. You cannot do that. Okay, go with this 30. Yeah, this process is what the best process what you can apply. Yep, another of the same type, that is integral of x square log x dx. Okay, so even here also I'm going to apply the same process. What will be it for differentiable function and what is the integrable function? What am I choosing here is what very, very important, right? So obviously x square only will be my differentiable function, what I am considering. Okay, so x square 2x 2 with a 0. Got it? Right. Now going with log x. Right. So when we are going by this way, so integrate log x. So log x integration, what is it? Do you think log x integration is that easy? So what is integral of log x? What do we have to consider here? Log x into 1 again. So first function into integral of second minus integral of derivative of first into integral of second. So all this is what we need to do for every step. That becomes quite lengthy. So there are methods of integrating. Whichever is the best method is what we need to choose here, isn't it? So for the earlier questions, we felt that this method is the best method. But now for this question, this method will not be working that easily for us, right? So we will apply the same old process, that is integral of x square. Yeah, so eyelid process is what we are going to go with. Eyelid in this, what is the first function? So logarithmic and then the algebraic. So that is nothing but log x into x square dx is what I am going to go with. Understood? So this is my first function and that is my second function. So just integrate first into integral of second. First is your log x into integral of second, that is x cube by 3 minus integral of derivative of first, that is 1 by x into integral of second, that is x cube by 3 plus c. Right? So these both get cancelled. This will be your x square by 3. Now you have got your log x into x cube by 3 minus 1 by 3 into x square, which is nothing but x cube by 3 plus c. So finally, that will be your output. So solving in 2 steps here is a better process than applying your differentiable and integrable technique here. So whichever you find easy for that particular problem is what you will be going with. All the methods of solving is what we are going to discuss before you, right? So choosing is your option now. So these are the few homework problems what you can consider. So x tan inverse x, the 35th question, x tan inverse x is what you can consider. So whether you want to apply the shortcut method or the original method, I think for this, the original method only would be a better suited option, isn't it? So inverse islate, if you observe ILATE, we've got inverse trigonometry here, isn't it? So this will be first and that will be the second option for us, right? So for this, and now start with that integration of first, yeah. So first function is tan inverse x into integral of second, which is nothing but x square by 2 minus integral of derivative of first. Differentiation of first is tan inverse x is nothing but 1 by 1 plus x square into integral of second, that is your x square by 2 dx. So what are we left with? You are left with tan inverse x into x square by 2 minus integral of, this is 1 by 2 out, that is your x square by 1 plus x square dx. So for these type of questions, you have x square by 1 plus x square dx. What do we have to do now? So some kind of manipulation is what we need to do here, because your denominator is f of x anukunte. If at all you take your denominator to be f of x, your f dash of x is not found in the numerator. So that could not be a better choice. So what is the manipulation that I can do here? That is nothing but consider plus 1 and minus 1. This is most important, which we have already done in our earlier sessions also, right? Fine. So this is tan inverse x into x square by 2 minus 1 by 2 into integral of, see, observe, x square plus 1 by x square plus, these two you consider as one set, the minus 1 is the other set. So this is nothing but integral of 1 minus 1 by 1 plus x square dx is what you have. Clear? So answer for this is integral of 1 is x minus integral of 1 plus x square is your tan inverse x plus c anyhow there, and rest all remains the same. That is what you can write. Clear? So that will be your final answer. That is for 35th question. Now for 36th question, what can be your first function and second function? Did you ever think about it? You have three functions here or two functions. Treat like, how do you relate them? Is it three functions or two functions? Cosecant x and cot x. X is one function, definitely. Cosecant x and cot x I am considering as my other function. So why do I have to consider this? Integrating cosecant x, cot x would be easy for me, isn't it? So tell me something. What is differentiation of cosecant x? dy dx of cosecant x. dy dx of cosecant x will be cosecant x cot x with a negative sign, isn't it? So integration of cosecant x cot x will be minus cosecant x. Got it? So I can integrate this function easily. Hence, that is my second function. X is my first function is what I consider. So for the 36th question, I'm doing here. So 36th question is first into integral of second. First is x into, what is integral of second? Integral of second, that will be your minus cosecant x, as we have just now seen, minus integral of derivative of first, which is 1, into integral of second, that is nothing but minus cosecant x dx. Clear? So minus of minus, this is minus cosecant x, minus of minus becomes your plus integral of cosecant x dx. So integral of cosecant x dx, what is it? That is nothing but log mod cosecant x minus cot x plus c. This remains the same. Is that clear? So that way you can proceed. Okay, so now how to go about with the question number 37, that is x cube cos x square dx. Think about this. What did I say? So let us consider x square equal to t, let us take, right? So obviously 2x dx equal to dt. All right. See, observe as x dx. So from here, x dx is 1 by 2 dt. Clear? So why can't I write this x cube as x square into x, so that this x will be mixing with dx? Clear? So I am rewriting the question x square cos x square into x dx for my suitable substitution. Now what is x square? T. What is cos x square? Cos t into x dx is nothing but 1 by 2 dt. Is that clear? So now the question looks simple for us. Now tell me the shortcut process is a better option or not, isn't it? So now that is your 1 by 2 into for t cos t. What is the differentiable function and what is the integrable function is what I'm going to write here, dear. Right. So obviously t and differentiation of t is 1 and its differentiation is 0 there. Next coming for cos t. Integration of cos t is sin t. Integration of sin t is minus cos t. Clear? Now, tell me cross this way and this way. So that is your t sin t and minus 1 into cos t. But first is a positive, second is a negative, hence minus of minus. So what is it? So that is your t sin t plus cos t is what you have. Clear? So half of, just apply that value here in your question. So half of t sin t plus cos t plus c. Now resubstituting back your t is most important. Okay. So which I need not do, but you have to do for every step, every question you need to complete it. Okay. So t is nothing but your x square sine x square plus this is nothing but cos x square plus c will be your final answer for the question. Right, now observe this question, sine root x dx. So whichever is irritating factor for us, root x, isn't it? So root x equal to t anedanikanna, better go with x equal to t square. Okay, so when your x equal to t square, obviously dx equal to 2t dt, right? So now just to replace, so this is nothing but your sine, root x is nothing but t, dx is nothing but 2t dt, right? So it is nothing but 2 integral of sine t into t dt, which I'm going again with my shortcut process only because my differentiable factor will be t, 1 and 0, isn't it? So that's the best thing what I can do. Now my integration will be sine t, whose integration will be minus cos t, whose integration again will be minus sine t. Right? Now, what is my next process? Ting, ting, cross, cross, cross. Isn't it? Now, let us do it directly with all the sign changes is what I'm going to do now, right? So now what is the answer here? So that is your minus cos t. So when I'm going here, it is positive. While I'm going here, it has to be taken a negative. Minus of minus plus sine t. Got it? So please take this substitution directly. Now, this is minus t cos t. Okay, so now this is nothing but 2 times minus t cos t plus sine t plus c is your final answer there. Answer the question very easily. Clear? Right, all these problems is what you need to solve them separately. Do it again. Wherever you need, pause it, check what was done, and then proceed. Please do not just copy from the board, which is of no use at all. Now, e to the power cube root of x dx is what we have. Now, what will be the suitable substitution here? So earlier, whenever we had root x, what did I take? So this value to be equal to t square is what I have considered, x equal to t square. Now I have a cube root x. Then what is this value? X equal to t cube is what I have to consider in order just to eliminate my cube root there, isn't it? So now let us take x equal to t cube. All right. So x equal to t cube, obviously dx equal to 3t square dt. Right. Just substitute now, which is nothing but e power cube root of x. What is cube root of x? Tell me from here. So your cube root of x is nothing but cube root of t cube, which is nothing but t, isn't it? So e to the power t dx is nothing but 3 I'm taking out. That is t square dt. Now again I have isolate, obviously e power t into t square. My differentiating factor would be t square, next 2t, next it is 2 and with a 0. Now integrating factor, obviously wonderful, isn't it? E power t, e power t, e power t, e power t, whatever you write, that is all e power t only. Now cross ting and this one. Obviously, now we have to go with a cross with directly sign changes is what I'm going to take. Now tell me e power t into t square. Next, this is anyhow a positive. Next with a negative. Next with a positive. Alternate positives and negatives is what I consider. Hence, it is minus 2t into e power t. Clear? Minus sign is what I'm considering there. Plus, that is 2e power t. So just apply all that here in your question and plus C, there ends your answer. Clear with that? All that you need to write it. All that you write it here and there ends your answer. Easy. Yes. Now the next question, the 40th question, the last question of this session is integral of x cube log x whole square dx. So here also, so what do I have to consider? Generally, if I consider log x equal to t, what happens? X is nothing but equal to e power t. Obviously, dx equal to e power t dt. Clear till this? Right. Now just substitute here. Now x is nothing but equal to e power t. I'm looking for x cube, which is nothing but e power 3t. Clear? So that is my e power 3t and log x is t. Hence it is t square and dx is nothing but e power t into dt. E power t into dt is my dx. Now finally e power t into e power t, which is nothing but e power 4t into t square dt is what I have. Right. Now, think about e power 4t and t square. Again, I late, which is nothing but I can go with my shortcut process. Differentiable factors and integrable things is what I'm considering. Differentiable is, yes, t square, 2t, 2 with a 0. Isn't it? Right. Next, go with the e power 4t. Do it carefully. E power 4t. E power 4t by 4, isn't it? Next, e power 4t by 4 already there. Another 4 comes by 16. Clear? Understood that? Next, again, e power 4t by 16 already there. Another by 4 comes by 64. And now take a cross here, and cross here. Right. So t square e power 4t by 4. Next goes with a minus sign, isn't it? Minus 2t e power 4t by 16. Next it is plus only 2 e power 4t by 64. Clear? So do all that calculation. So final answer will turn out to be all this calculation is what you do and check it. Clear? So all this will be replaced here with plus C there. So that's it. So all these models are very, very important models. Please see that you solve each and every question on your own without looking at the question there on the board. Wherever you find any difficulty, please go back and check. Pause the video, go back and check how it is done and then do it yourself. Clear? Good luck. Bye-bye.